Have you ever wondered why ice floats on water? It's a simple question with a fascinating scientific answer. Most substances become denser when they transition from a liquid to a solid state. Ice, however, behaves differently. It's this unique property that makes ice so important to our planet and our lives. We often take it for granted, but the fact that ice floats is truly remarkable. Imagine a world where ice sank to the bottom of lakes and oceans. Life as we know it would be impossible. Let's delve into the science behind this phenomenon and understand why ice floats. Water is made up of tiny particles called molecules. A water molecule consists of one oxygen atom and two hydrogen atoms. These atoms are bonded together in a specific arrangement. In liquid water, these molecules are close together and move around freely. When water freezes, something interesting happens. The water molecules slow down and arrange themselves into a crystalline structure. This structure has more space between the molecules compared to liquid water. The result is ice, a solid form of water with a unique arrangement of molecules. This arrangement creates open spaces within the ice crystal lattice. These spaces are larger than the spaces between molecules in liquid water. This difference in spacing is crucial to understanding why ice floats. Density is a measure of how much mass is contained in a given volume. Objects less dense than a liquid will float on its surface. Objects denser than the liquid will sink. Think about a cork floating on water versus a rock sinking to the bottom. Because of the increased space between molecules and its crystal structure, ice is about 9% less dense than liquid water. This means that a given volume of ice weighs slightly less than the same volume of liquid water. That's why ice floats. Imagine a lake in winter. As the air temperature drops, the surface water cools and eventually freezes into ice. Since ice is less dense, it floats on the surface of the lake. This floating layer of ice acts as an insulator, preventing the water below from freezing solid. The fact that ice floats has profound implications for life on Earth. If ice sank, lakes and oceans would freeze from the bottom up. Aquatic life would be unable to survive in these conditions. Floating ice also plays a role in regulating Earth's climate. The bright white surface of ice reflects sunlight back into space. This reflectivity, known as albedo, helps to moderate global temperatures. The floating ice caps at the poles are crucial habitats for a variety of species, including polar bears, seals, and penguins. These animals rely on the ice for hunting, breeding, and raising their young. The stability of these ecosystems is directly linked to the unique property of floating ice. In conclusion, the ability of ice to float is a consequence of its molecular structure and lower density compared to liquid water. This seemingly simple phenomenon has profound implications for life on Earth, from the survival of aquatic ecosystems to the regulation of global climate. So, the next time you see ice floating in your glass of water, take a moment to appreciate the science behind this fascinating and important phenomenon. Fun fact: did you know that hot water can sometimes freeze faster than cold water? This phenomenon, known as the Mpemba effect, is still not fully understood by scientists.